where you find and can utilize bacteria at an opportunity to work on the North Slope of Alaska for a while, and below the permafrost, and you're about 9,000 feet and it's about 230 degrees Fahrenheit, we isolated bacteria, and you had to culture them and keep them in boiling water, or they would die. And it always intrigued me that you go up to Alaska, you go through the permafrost, and you got little critters down there that will die if they don't have boiling water around. But we'll take a rest break right now for about 10 minutes, and get back together about 20 after, and we'll continue. Paper is by John Schabron from Western Research, and the title of the paper is A Legacy of Contributions to the Petroleum Industry from Western Research Institute.
Thanks, Norm. Norm twisted my arm to put together a presentation on the history of the Institute. It's a fairly large responsibility. I hope I've done it justice. A couple of pointers at the beginning. One is that I'm going to talk about contributions to the petroleum industry. Some of the other achievements aren't going to be mentioned in any detail. Second is I'm an analytical chemist. I'm biased towards the innovations in analytical chemistry that have come out of the Institute over the last 80 years. So those are the things I'm highlighting. 80 years is a long time of history to go back over. Again, it's a pretty significant responsibility. I hope I've got it all right. If you want to add some things at the end, please do so. We'll start out with Lake Marie here up on the slide. That's 35 minutes from my house. It's about 11,000 feet. That was taken last August, and yes, that's still snow up there. That road is closed during the winter, but we do enjoy it as much as we can during the summer. In 1924, the federal government U.S. Bureau of Mines established a petroleum research facility on the University of Wyoming campus in Laramie, Wyoming. The facility was to be involved with issues related to heavy oil, Wyoming oils, tar sand, oil shale, and underground coal gasification. And indeed, in one form or another, that mission continued into the 1980s. In the 1970s, the U.S. Department of Energy, Laramie Energy Technology Center, was responsible for Western energy resource development. Millions of dollars of funding flowed through the center at the time. It was the center of the oil shale activity until the mid-1980s. In 1983, the center, as it's known to the locals in Laramie, or the Bureau, was defederalized as the University of Wyoming Research Corporation, doing business as Western Research Institute. Now, the relationship with the university is a little difficult to understand, but basically the employees of WRI are not university employees, they're not state employees, but the university trustees appoint the board of directors. And the facility is, the legal entity is the University of Wyoming Research Corporation. So figure that out. Today, we're a nonprofit research institute, technology development center performing contract research for federal government entities, state governments, and commercial clients. This is our Laramie, Wyoming headquarters on the northwest corner of the University of Wyoming campus. This building was constructed in 1947, shortly after World War II, so there's very little steel in it. Native sandstone is what the skin is made of, as is the same type of structure around the university campus. A little ways north of town, We have an advanced technology center. It's a 22-acre site. It was the site of a lot of the pilot plant activities, the oil shale retorts in the 1970s and 80s. This actually is a dated picture now. We have put siding on many of the buildings and upgraded the site. We just couldn't get the aerial photo soon enough for this presentation. This is mostly where the engineers work with the big toys. I'm going to go over some history of the Institute and some significant achievements over the years. In the area of petroleum, the Institute was heavily involved in the API projects for characterizing petroleum. The Institute also was the National Center for Oil Shale Development, tar sands, and underground coal gasification activities. Let me go back to the defederalization briefly. In 1983, there were 5 fossil energy centers in the United States. Morgantown, Pittsburgh, Grand Forks, North Dakota, Bartlesville, Oklahoma, and Laramie, Wyoming. In '83, the 3 centers west of the Mississippi River were defederalized. Since then, Morgantown and Pittsburgh have merged and have now become the National Energy Technology Laboratory. Much of our funding comes through this facility in the Pennsylvania, West Virginia area. Okay, timeline overview. 1924, the Petroleum Field Office for the U.S. Bureau of Mines was established in Laramie. Again, Center for R&D on heavy oil, tar sand, oil shale, underground coal gasification, as I mentioned. The center was actually closed for 2 years during the Depression. There was no funding. In 1935, the center opened again as the U.S. Bureau of Mines Petroleum Experimental Station. During World War II, the Synthetic Fuels Act was passed, and the center's name changed to the Petroleum Oil Shale Experimental Section, and major efforts began into the development of oil shale extraction technology. Again, as I mentioned, in 1947, the new building was completed on the UW campus. And shortly after that, the Institute, the Bureau, became heavily involved in 3 API projects. One was the API 48 project, the API 52 project, and then later the API 60 project. The API 48 project was set up to identify and determine properties of sulfur-containing compounds in crude oil. We heard the talk earlier that in the 1940s there wasn't a lot known about sulfur compounds or nitrogen compounds. And the API 52 project was a similar project that was established to identify and determine properties of nitrogen compounds. These separation steps that were employed did not use gas chromatography or liquid chromatography. They were very meticulous distillation and physical separations. As a matter of fact, when I joined the Institute 20 years ago, we still had a room at the lower level where these standards from these API projects were kept in sealed glass vials. Since then, they've gradually been disposed of as everybody needs to clear out their unused chemical inventories. The API 60 project had a little different slant to it. This project was aimed at separating and characterizing fractions from heavy oils. Bartlesville office was the petroleum center for the nation. The Bartlesville group participated by preparing 3 distillate cuts of 8 to 10 heavy oils, a middle distillate, a vacuum distillation cut, and the vacuum residuum. This was the first time that some of the new sophisticated liquid chromatography techniques were employed to separate heavy oils into fractions that were subsequently characterized by a variety of techniques, including mass spectrometry and other optical spectroscopy techniques. The separations and the characterization work, primarily the separation work, was conducted at Laramie. I want to list a few methods. Again, I'm telling you, my bias is towards analytical. A few methods that emerged from the Laramie Center that are still important today. ASTM D3904 is a Fisher assay method, which is the standard method for determining how much shale is in oil shale. This is in terms of gallons per ton. For example, 50 gallons per ton is a very good resource. This involves coffee pot size retorts, aluminum retorts that are heated to 500 degrees centigrade. And the oil is then, oil and water comes out basically in gas. And a variant on this is the mass balance Fisher assay, where the assay is run in a sealed stainless steel container and all the gaseous products are analyzed. The chromatographic methods, the liquid chromatography methods, the people who spearheaded this were Doug Jewell, DeWitt Latham, Bill Haynes, John McKay, Henry Plancher. And of course, you all know that about this time that Lloyd Snyder also was working in the area of linear elution absorption chromatography to provide the same type of separation profiles regardless of the sample type. We weren't overloading the columns. Separation method called the SARA method, the saturates, aromatics, resins, and asphaltenes, and other groups and other oil companies worked on variants of these techniques also. Where asphaltenes were isolated first, and then the remaining maltines were separated into 3 fractions. Non-aqueous ion exchange chromatography at preparative level took this to another step. In this case, often asphaltenes were not removed first from the oil. The entire oil, or the fraction, the distillation fraction, was separated to remove acids, in some cases weak acids, strong acids, bases, weak and strong, neutral, nitrogen neutral fractions, saturate aromatic fractions. And then preparative gel permeation chromatography was practiced at the center. A couple of illustrations. The Fisher assay method, again, as I mentioned, involves taking a shale sample, a couple hundred grams ground up into a coffee pot sized retort, and there's a temperature profile in the ASTM method that ramps it up to 500 degrees centigrade under a certain rate of heating. And the oil and water basically flows into a vessel in an ice bath. You volumetrically look at it and measure the oil. There's a lot of oil. There's a lot of oil shale in the United States. There's more oil in the shale in the U.S. than there is oil in Saudi Arabia. Primarily centered western shale in the western Wyoming, eastern Utah, western Colorado, the Uinta Basin, the Great Divide Basin, Green River Basin, and the Piceance Creek Basin. We've got it there. It's a matter of extracting it, and there are environmental issues involved. Chromatographic separations. This is one example of the SARA separation taken from this book that was written in 1979 and hasn't been rewritten since. Chromatography, petroleum analysis. Again, Doug Jewell, D. Latham, Klaus Altgeld described the separation on a clay gel type column into the saturate aromatic and resins fractions. And this is a separation that we have employed recently. It's based on the same idea, where you take about 16 grams of a residuum and obtain fractions, and you can actually do a variety of detailed characterization work on the fractions. The ion exchange chromatography method is an alternate way of doing a separation to obtain fractions for subsequent analysis. We also have performed this. These columns are about 4 feet tall and 2 or 3 inches in diameter. This is again out of the 1979 book on chromatography and petroleum analysis, showing the removal of acids. Acids are usually removed first because they're the most active species, and they're the ones you can get out easily at the beginning. Again, this is one we've practiced under characterization contracts where we basically obtained 4 fractions. In this case, we did separate out asphaltenes first for subsequent analysis. There's a variety of permutations of these techniques. We've also separated asphaltene material using preparative gel permeation chromatography on a styrene divinyl benzene gel to obtain fractions for characterization. In cases like this, we found, for example, the early eluting material has a nominal vapor pressure osmometry molecular weight of 40,000, and this material registers an apparent molecular weight of 1,200, and these are mostly due to associated complexes. Other historical methods developed at the center, Webb Robinson and Glenn Cook were proponents of a hydrocarbon type by low resolution mass spectrometry. This is the Z series method, where you determine, this works for hydrocarbons, it doesn't work for heteroatomic species. It's Cn, 2n plus Z, and the Z tells you what type of hydrocarbon you're dealing with. High resolution mass spectrometry for a computer-based method for assigning empirical formulas. Jim Weber and Frank Guffey at the center developed that. Frank is still an employee at the center. The pedestal freeze-thaw test for prediction of asphalt failure due to freeze-thaw cycles is currently in use, developed by Henry Plancher. The differential infrared functional group analysis method measures 7 functional groups in asphalt and heavy oils. Clayton Peterson, who's retired from our center, developed that method in the late 70s. This is a photograph of the pedestal freeze-thaw test. Basically, this is an asphalt aggregate coupon that is pressed, in the laboratory pressed, and this is a pedestal, sort of a cone shape. The coupon is placed on the pedestal in the jar, half filled with water, and you simply freeze it, thaw it, and you count how many times to do that before the sample falls apart. And that's some indication of the tendency, the robustness of the asphalt aggregate mixture to withstand damage from freeze-thaw cycles. Some water, moisture damage is a current problem we're looking at intently. This is the infrared functional group analysis developed by Clayton Peterson. It is in routine use in our laboratory. It's very important, for example, in some paving asphalt materials, to know something about the sulfoxide compounds. Several sulfur species oxidize to sulfoxides, they become natural surfactants, and that result in damage when they are contacted with water. Some more recently developed methods. ASTM D6703 was promulgated about 2 years ago, in 2002. Standard test method for automated high-house titrimetry. This is the stability titration to determine p-values. Troy Pauly built a device which was awarded a 2002 ACS Regional Industrial Innovation Award. ASTM D5831 is more on the environmental end of things. Standard test method for screening fuels in soil. And that was, again, awarded an ACS Regional Industrial Innovation Award in 2001. The WRI Coking Index is a methodology that we're promulgating and currently developing some online real-time analysis capability to perform. This method provides an indication of how severely a heavy oil has been cracked, whether it's a vacuum bottoms, an atmospheric bottoms, or abyss broken oil. It's worked with every oil we've looked at so far. This is a photograph of the titrometer. This is a research instrument primarily. It has modules, it has temperature control, computer, it uses a spectrometer. You can scan different wavelengths. We usually stay at around 740 nanometers. This is about the same red light as this laser. The automated flocculation titrometer provides a very useful range of data. The stability compatibility value P, which is sort of a universal number thrown around by the oil industry. The coking index is a ratio of 2 of the terms. Again, if that value is near 0, it tells you that you're making coke or about to make coke. You have microscopic pre-coke particles. It gives you the solubility parameter of flocculation. It gives you the solubility parameter of the whole oil. The bound solid volume fraction, which is an important predictor into heat-induced deposition and coking propensity. It lets you calculate this free solid volume to help you rank heavy oils and residual. And the blending numbers developed by our wiki at Exxon basically come out of these solubility parameters. The titrometer does all that in about 15 minutes. This is a picture of Brian Laramie doing some field analysis using the diesel dog soil test kit, or the ASTM D5831. These are some details. This is on the coking index. This is based on the dispersed particle solution model. Basically, we have an index that shows the protective layer around the asphaltene being destroyed by thermal treatment, by pyrolytic thermal treatment. And there's a threshold value below which coke forms for every material we've looked at. Again, vacuum resid, atmospheric resid, or visbroken oil. The main utility of this is that if you're distilling an oil prior to generating a bottomless material, either for a delayed coke or to sell as an asphalt, if you stop distilling with the K value of around 5.5, and I'm not going to go into the theoretical description of the K value, but this again has to do with the overall stability of the system, in that the resinous, the intermediate polarity material has not been destroyed. You could still distill that and crack it and take it down to about 4.5 safely and have a relatively stable oil and squeeze another % or 2 of distillate out of it. That's kind of what we're aiming at, is to come up with a tool so a refiner can do inline, continuous monitoring of the process. Other petroleum-related work, we're exploring partial upgrading, WRI thermal treatment process for partial upgrading of heavy oils. Why are we doing this? Up in Canada, again, the Athabasca tar sand projects generate a heavy bitumen that has to be diluted with the diluent, put into a pipeline, shipped down south, diluent removed, shipped back up through another pipeline. This is basically a thermal process to crack the oil and stabilize it so that you don't need the diluent. Oil and gas production, we have a couple of folks that are involved in supporting the oil and gas industry, primarily in the Wyoming region. We've done simulation and process development assistance activities. Again, partial upgrading, a couple slides on this. It involves distillation, cracking, coke formation of stabilized light ends so that the thing can be pipelined without diluent. And there's a sort of schematic of the process. Oil and gas production, we do have laboratory facilities for 1- and 3-dimensional simulation capabilities. We do numerical simulation. We've developed some new oil and gas production treatment processes and have demonstrated some processes in the field, especially some of these places where you have isolated production, and you usually would vent the methane. Now we've got to come up with some things to do with some of these light ends. We've done thermal recovery processes, forward and reverse combustion, gas injection, re-injection of dry process gases, CO2 injection, immiscible gas injection, some shallow sand production, surface processing, water flood through horizontal wells, and wettability enhancement. This is primarily, again, Lyle Johnson and Charles Mones. Technical meetings. The Institute has a history, and some of you may fondly remember some of the technical meetings that were sponsored by the Bureau or the Center over the years. It's confab. This started out as the API meeting, starting out with the API 48 project. This ran all the way up to 1992. I was at the last confab in Winter Park, Colorado. I was actually a graduate student, and I did attend this for the day. I'm not in the picture. In 1976, that was at the University of Wyoming Science Camp, not far from the lake. The picture I showed you on the first slide, the cabins weren't heated. These folks had to go out and cut wood. They enjoyed it. And there was a book for each meeting with photographs. It's a who's who of petroleum research chemists of the era in the 50s, 60s, and 70s. Those records are just fun to look at. We currently conduct the Peterson Asphalt Research Conference. This is Clayton Peterson, who's a retired distinguished scientist who helped actually put together the SHARP Strategic Highway Research Program years ago. This conference is held annually during the summer in Wyoming. This year it was in Cheyenne, in the past it's been in Laramie. And about 130 to 150 asphalt heavy oil researchers from around the world come and discuss issues relative to them. Other technical meetings, the Institute and the Center has participated in organizing the Oil Shale Symposium with the Colorado School of Mines, which ran from about 1967 to 92. The Rocky Mountain Conference on Analytical Chemistry is held in Denver annually every August. Start out as a Society for Applied Spectroscopy meetings organized by personnel from the Laramie Center, especially Dan Hutzel. It's one of the premier NMR meetings in the world. Fossil Energy Advisory Committee in the 1970s, this was Department of Energy advisory groups. Sub by 2 Minutes Energy Coalition is one that started 2 years ago, organized by Al Bland. This group brings together members of the coal industry and the utility industry that burns coal, and they're especially concerned with issues related to upcoming regulations in cap and trade for mercury, for example. These are important issues, and this is what is currently needed and currently hot, if you will. Current program structure at the Institute, basically it's fossil energy and related environmental issues, technology development, problem solving, contract research. Again, fossil energy I put up here because this is a petroleum talk. We are involved in petroleum production and upgrading, research, technology development. Residual characterization, we're always available to do that. And we do a lot of troubleshooting for people who have problems in the asphalt industry, applying some of these separation tools I talked about. We do a lot of research in coal utilization of coal bed methane and the tremendous amount of water that's produced because of coal bed methane and issues related to what do these people in the dry lands do with all this water. Renewable energy, we are involved in biomass conversion. Environmental remediation, petroleum contaminated soil. We do have a field project in Egypt looking at bugs again that survive at high temperatures. Mercury removal from coal, we have a patented process. We're actually built a pilot facility now to remove 75% of the mercury from coal before it goes to combustion. Field analysis technology, we have several different technologies used for environmental field analysis. Highway materials, asphalt, close to half our budget is on highway research for the Federal Highway Administration. We're a national center in highway research. We have, as I mentioned, we have about half our funding comes from the Federal Highway Administration. The other half approximately comes from the Department of Energy. 2 programs. The base program is established for exploratory and development research, new technology development. The jointly sponsored research program is actually the bulk of the cooperative agreements. These involve cost share projects with industry, and DOE will provide up to 50% match. And we aim at commercialization of technologies. We basically share our cooperative agreement funding with the Grand Forks, North Dakota Center. So that funding is allocated to both centers and divided down the middle. We have 4 co-sponsors of our heavy oil and stability research, and this I really appreciate because it helps keep us relevant, keeps us looking at problems that are relevant to the industry. Chevron, Texaco, ConocoPhillips, ExxonMobil, and GE Betts. We've done contract petroleum research. We've done some very proprietary research. In a couple of cases, we've been requested not to reveal the names of the companies that hired us. We did have an opportunity to do some high-profile work sponsored by Mobil and U.S. Department of Energy to separate and characterize 6 petroleum residuals. The stipulation there was we don't identify the residual. We can talk about the results, but not what oils we looked at. We've done proprietary research.